Hey, hello everyone. I will start today's material. This material is about how to use the OpenCV library, especially in the Colab environment. So I will first introduce you about how we can use the Google Colab and how to upload the files into the Google Colab environment. And actually, there are two popular ways to upload the files in the Colab. So you will see that. And after that, I will upload the image and video files into the Colab and uh, I mean, lecture how we can use the OpenCV library that can edit those image files. Okay. So this is the brief introduction about the Google Colab. So that is the free cloud service that provide us some GPU access uh, for AI developers. So this is given to the users who have the Gmail account. So most of you already have the Gmail account, so you can use your own Gmail account. Given this your own Gmail account, this one GPU is freely available to you. And this service is provided by Google, and also you can code the Python and and its libraries in this environment. So you can follow this link. Okay, sorry. So I already opened this collab here. So I mean, when you originally type this address, then you will see this kind of window. If you already have accessed the collab before, then you can see previous files you already loaded, unless you will not see this. Okay. Anyways, click cancel and you can make new notebook here. So, and also you can save your I mean, this environment is called as the notebook, so you can save your own notebook into the file, or you can load it again when after saving it. Okay. So this is new to our notebook. So I will usually make the notebook here. Then you will see this kind of window. So you can type any Python language here, hello world, and you can click this to execute it. Yeah, then this appeared. This is the result, okay, of this code. Okay, so this is the easy kind of the interface that code your own code. Type your own code. Yeah, this is called as the notebook, and you can type any Python code here, okay? And see the result directly by clicking this button, okay? And you can also see, you can also upload. This is upload, and this is the refresh, and yeah, this is the button for mounting your Google Drive here. And yeah, this is option for showing hidden files maybe, but there is no actually files uploaded yet. Okay, but uh, when dealing with many computer vision algorithms, you need to input the images, and those images are contained in the files, okay, as the JPEG or BMP, PNG, and diverse image format. They are saved as the files. Okay, so you have to upload those image files into this storage and have to access it from the code. Okay, so for doing that, I already uploaded So this is actually introduction about the collab, and this is the how to make the new notebook and how to type Python code. Okay, you can type this kind of code in the collab, and if you click this button, then it simply works. Okay, that's the collab environment. And now to practice this OpenCV library in the Google Colab environment, you have to download a few files. So if you follow this link, then you can see this kind of link. Okay, that's the Google Drive address of mine. So I uploaded four files, the two JPEG files, which is the image, which are images. Okay, and this is the AVI file, which is the video file. Okay, and this is IPYMB file. This is the notebook that I typed, that I made in the Google Colab. So I already said you if you type this kind of code, then you already made the notebook here and you type the code. Then if you save your notebook, then you can actually download it as the IPYMB format. And this is kind of the file that contains your notebook environment. Then after saving that, after downloading that, you can also upload the notebook file, or you can also open already uploaded notebook file. Okay. So let's see. I already downloaded those Google Colab, the files contained in my Google Drive. And this is the four files I already introduced to you, okay? So, I mean, this IPYMB file, I will upload it in my Google Colab environment, okay? So you can load it here. Yeah. Then you will see this kind of materials, and it actually contains the materials I have in this kind of PPT. Yeah. So you can download this PPT in the Blackboard. Okay. So I uploaded the code I used in this IPYMB file. Okay. And I will step by step execute this code. Let's execute the first thing. Okay, so this message outcomes because I have multiple collab sessions, so I will close this and then click it again. I will delete other things. Uh, I will delete that for other sessions. Again, I will. Okay, there's no other session. Yeah. Now it should work, but it says some error. So it is saying that maybe because it doesn't have this kind of file within this Google Colab environment, the error might comes out. So I will upload these three remaining binary files, which is images and videos, and then we will run this code again. Then now you can see this image is properly loaded. Okay, so what the code here is doing is import the OpenCV library and call this imRead function that can read the image files, okay? And then this img array variable is having the image data. And then by calling this cv2 on the imshow function, then you can visualize these images, okay? I mean, this OpenCV library is abbreviation for this open source computer vision library. Okay, so it is the library open sourced for computer vision tasks. Okay, so it provides very easy interface to code image processing algorithms, and it is compatible with C, C++, Java, Python, and other languages. So it is very easy to use, okay, in diverse languages. In Python, it is even very easy to use this library. You can just import this OpenCV in the Python code. So as you see here, the thing you need to do is just import CV2, but you in your local machine, you have to install this library properly, okay? Please Google it to install this library. But in the Colab, this OpenCV is already installed, so you don't have to care about installing that. And this function CV2IMShow, this is special function because this is not console. So when you code your own code in the in your local machine, you don't have to use this cv2 underbar imshow, but instead just use cv2.imshow. So this is special function dedicated to the Google Colab environment. Anyways, you can use this function to visualize images. Okay. This is web browser environment. So Google Colab requires this kind of special function, but in your local machine, you don't have to consider this. Okay. So what I want to tell here is, I mean, sometimes just loading the image files that could be very difficult. So for example, when you try to open the JPEG file or BMP file or PNG file or other types of the image files, you have to study what kind of format these file types are having. Okay? For example, you have to first parse, the image files are binary files, so you have to load them in the binary mode. I mean, in the opening file, computer files, you are having two mode. One is the binary, one is the text, right? Image files are written in binary mode, and you have to load the image files in the binary mode, okay? And then you have to first parse the the uh, data header first. So data header have the information about the width and height and channel numbers and so on. And then it may have some of the more information, especially for the JPEG, because it is the compressed image format. So anyways, you have to study how those pixel values are compressed, and actually you have to implement how to decompress those pixels from the raw files. Okay. And also PNG or BMP, those are non-compression algorithms, but still you have to load the header properly by studying their format. So this kind of thing could take your effort. Okay. Implementing just loading the images in Python code, it may take few hours if you don't know their format, okay? You have to study them first, okay? So, I mean, but this OpenCV library makes this kind of thing very easy. So you don't have to study the image format. Instead, you can just call imRead function, image read function, okay, and just type their, how to say, their file name, and with some flags. So this flag here is meaning does not change anything about the original image. Okay. So then this img variable is I mean contained with the the raw data saved in this JPEG file. Okay. For loading other types of file, you can just change this to PNG or other types. Okay. Inside the imread file, everything is already implemented by experts. So you don't have to care about their details, how to load those data, but just care about, just you can specify you want to read those files here. Okay. It's very easy to use library. Okay. And also, when you upload the files in this directory, that folder name is slash content slash. Okay, so because of that, you can just load these past files. Okay, and I'd like to introduce another way to upload your own file in this collab environment. Okay, I mean, if uh, I showed you one way here, you can just upload them in this local drive, right? But thing is, if you close this collab environment and reload it, then these files are deleted, automatically deleted. Okay, that's disadvantage of directly uploading these files. I mean, imagine that these files are now very small, right? But imagine that these files are relatively bigger, and it may take few hours to upload it into this environment. Then you mistakenly close this window, then it may be disaster, right? You have to wait another few hours to upload those files in this environment. Okay, so in that case, where your files which have to be uploaded is big, relatively big, and if it takes few hours, as I exemplified, then the thing you can do is uh, you can mount, you can actually mount, how to say, uh, you can actually here, sorry. You can actually mount your own Google Drive. Okay, so for example, this is the code, uh, I mean, that can connect your own Google Drive to your Google Colab environment. So Google Drive is also free if you have a Gmail account, right? So you can, pre-upload your files in your Google Drive, then you can execute this type of code, okay? Then you can click this connect to Google Drive, and you have to, sign in your Google account again. Okay, so you have to do this kind of verification. Okay, then after this kind of verification step, it may take few seconds. Then you can see this kind of message. Then you can find that this new folder is generated. And if you open it, you can freely access your own Google Drive environment. So this is why I'm telling you that you can upload big files in your Google Drive, and then you can just mount that to use them as, use them from the Google Colab code. Okay, that is another way to upload your own code, your own data. Okay, so if your data is relatively big, then you can take this kind of thing. Okay, and also in the assignments, this definitely this kind of method is useful. Okay, okay. So this is the first practice. And the other thing is you can just change this kind of flag. Okay. Previously, it is meaning don't change any low image files, but here you can specify that you want to read it in the grayscale image. Then the images are loaded in the grayscale. Okay. And also you can access you can this variable, the img that contains the raw data, can be regarded as just the, just general variable in the Python. So if you print out this dot shape, then you can actually get this type of size. So it is meaning that this is height, this is the width, and this is the channel number. So the image array looks like this. Interestingly, the height goes first, width next, and channel numbers next. Okay. And also, this channel number, it should have three channels because it is the color image. Okay. And the first channel is not R channel, but it is the B channel. It's in the BGR order. Okay. So, I don't know why it happens like that, but OpenCV always load the images in the BGR order. And also you can access each image pixels by doing this. So this is selecting the left topmost. This is the topmost pixel, and this is indicating the leftmost pixel. So this is indicating the pixel values of the left topmost pixel. Okay, so that's blue color is 182, and this 115 is meaning their green color, and this is meaning their red color. So indeed, this pixel is having blue color. Okay, so you can see this is the pixel values for the left topmost pixel. And also you can also access the first dimension of this channel, okay, that would be 182. So you can see you can directly access the pixel values in the code level, okay, that is very useful information. And also you can visualize. This is also similar to the general Python grammar. Okay, so this this indicates you will select all the column. Okay, and also you will select all the column, but select only the blue channel. So this image is meaning blue channels of the original image. Okay. And also later I will show you some powerful functions of the OpenCV library, and you can roughly think what you can do using your Photoshop application. You can do those things in OpenCV. Okay. Theoretically, if you can do that in Photoshop, then you can do that in your OpenCV library. Okay, you can think like that. So, for example, you will first read the images. You will load the image from this file, and then you will draw some rectangles in those image. Okay, and you will show that image here. Then you can see this kind of rectangles. Okay. And this is meaning this is the starting point and this is the end point. And this is the color of the line. Okay. And this is the thickness of the line. And if this is -1, then it is meaning that you want to fill those rectangles. Okay. There are many options here. Okay. And another thing is, you can, if you want to draw some polylines like this, then the thing you have to do is, you have to indicate some of the point 50 comma 50 here, 150 comma 150 here, and 100 comma 140 here, 200 comma 240 here. And then if you insert those points you defined here in this polylines function, and you can see this kind of polylines, and this is the line color. Okay. Yeah, you can do this kind of thing. And for rest of options, I'm not also familiar with, but you can search for these functions in the Google. Okay, so yeah, please try changing that. And also you can also draw some circles or ellipse. Okay, so this is the circle drawn by this code. Okay, this is might be the center position, and this is the radius, and this is the color. Okay, and this is similar. So this is center, maybe. Yeah. Anyways, you have to check the exact grammar for this. Okay, this is color, and this is the thickness. Okay. Anyways, you can draw ellipse and circles using the OpenCV library. And you can also draw some text in your own image. Okay, so this is the original image. This is the some message you want to put, and this is the location, and this is font and font size and color. Okay, you can do that with the one line of code. This is I mean, very powerful functions from the OpenCV. And also you can resize your own image. This is the original image, but you can resize it by half. You can half the original image. Even you can double the original image. Okay. And you can visualize all of the image at once. Okay. And also, yeah, also, I mean, explain about this blurring that is actually same as applying the 2D convolution operation in the original image. For doing that, you can just read image and apply this blurring. Okay, so, and this 10 by 10 is actually corresponding to the filter size. Okay, so for doing this blurring, you can think we are using 10 by 10 filter, but if you reduce this filter size, then it's less blurred. Okay. This is more blurred than before, and if you raise this filter size, then it becomes more blurred. Okay, so this is kind of the hyperparameter in 2D convolution. Okay, so you can easily check their effect here. Okay, and also this OpenCV library is implementing diverse image processing algorithm. So for example, this is the edge detection algorithm whose name is called as Kenny edge detector. And this is some hyperparameters for that. So you can see this kind of edge is meaning the boundary of each object. Okay, so from this image, you can detect some edges of that object. Okay, so also you can change these parameters. Okay, and the characteristics are slightly changed. Okay, so yeah, and also you can do some corner detection algorithm whose name is Harris corner detector. Okay. For doing that, I mean, you can actually detect some corners of the object with the one line of code. Okay. Corner is meaning the horizon and vertical components are meeting. Then we call it as the corner. And this Harris corner detector is very famous algorithm in image processing domain. It takes few hours, maybe few days, maybe, to implement this algorithm by yourself. But you can just type one line of code to doing this corner detection. Okay, and this is for making this color image into the grayscale image, and then apply Harris corner detector on that grayscale image with some of the hyperparameters. And this is the detected corner. And this part is for visualizing this red circle for the detected corners. So you can see this kind of circle. So this X and Y in code is taking some XY positions of the corner, and you are making some circles for that locations. Okay? So, I mean, I want to show that this kind of complicated image processing algorithm can be learned with a line of code in OpenCV. Okay, so want to show you that OpenCV is very powerful. And also, we uploaded this example.jpg and example4.jpg. Okay, and what we want to do here is these two images are having the same object, okay, with a slightly different positions. Okay, and here what they want to achieve is want to make it into the grayscale image and detect some features inside in both images, and they want to match the same uh, point in different images. Okay, so these matches are having those pixels which are matched, and this is actually the code for drawing the matched point. So this is called as the image process. This is the image processing algorithm called as the image matching. And this is very complex algorithm, but you can achieve it with a few lines of code in OpenCV. Okay, and also, yeah, you can also read. The other thing I want to show you is this is generated already. I will delete that. So after editing the images, you may want to save those edited images as the file again. So in that case, you can just use this imWrite function. So this is the code for read the images, okay? And then you can save it by manipulating, drawing some circle, ellipse, or doing this kind of complex algorithms on the images. And then you want to save it as the new file, okay? So here we do very simple thing. We read the image in the grayscale, and then we will save it again into the example2.jpg. Then you can see here, example2.jpg is saved here. Okay, if you download that, then you can see this kind of grayscale images are saved in this file. And the next thing we want to do is loading the videos. Okay, sometimes even loading video is very complex. Okay, because there are more and more types of video uh, codec. So you have to study codec to decompile these kind of AVI files. Okay, it's very complex. So implementing those kind of thing, loading the video can be almost takes few days if you want to implement that by yourself. Okay, but this OpenCV provides you very easy interface to load the video. Okay, so this is CAP is becoming the video loader, and if you call this function cap.read, then this one frame is loaded here, okay, and you can visualize it until it returns false. It returns false when it meets the last frame, okay. So this is the video frames loaded. So this each rectangle is having the is the frame, video frame. Okay. So this is everything I have in this material. Okay. So I think most of you are, some of you are already familiar with this OpenCV, but if you think you are not familiar with this kind of thing, then practice this, okay, in the Colab. This is very easy, actually, okay. And another thing is this OpenCV library is, as I already mentioned, this is the open sourced library, okay? And actually it is still expanding, okay? So if you search for, in your Google, uh, if you search for this OpenCV library, you can access the OpenCV website. And in their website, there are providing many examples for new features of the functions. Okay. And they also introduce new functions newly implemented. Okay. So you can refer those new functions in OpenCV. Okay. So and for the details of this, I mean, each, I mean, examples, I don't want to explain those details because I just want to show you their uh, OpenCV, show that OpenCV is powerful to process these images. Okay, I want to go into the details actually. Okay, so anyways, all right, so. This is everything that I want to share within this lecture today. So thanks for listening anyways. And if you have any questions, please use the Blackboard to upload your Q&A. Okay. Okay. Anyways, thank you and see you this Wednesday. Okay. Thank you.